Hello, this is the fifth video to polynomial functions and we will learn how to do synthetic division. So in the last video we learned how to do long division, and long division is very useful but it's very time consuming as well. So synthetic division is faster, some might say it's a little bit easier, and however it has some limitations. So here are the requirements. So you must be dividing a polynomial by a binomial of degree 1 with leading coefficient of 1. So what does this mean? That if you are dividing a polynomial, the denominator, or whatever you are dividing it by, must be x plus or minus something. However, if you had, for example, b times x plus or minus something, where b is just a constant, you could get around with it by factoring out the b. So let's call this a. So what you would do is take out the b, factor this out, leaving b times x plus minus b, a over b. And then you divide this by b to cancel this out, and you are left with a coefficient of 1, a leading coefficient of 1. So that's a way to get around with it, but we will first learn how to do it the simple way with just, in our case, we will do it with x minus 3. Having a leading coefficient of 1, this is a binomial with a degree of 1, so it fulfills all our requirements. So we will learn how to divide 4x to the fourth minus 6x cubed minus 12x squared minus 10x plus 2, and we will divide this by x minus 3. So the first step is to take a, so this is called our a, oh, just the 3, it has to be minus. So for example, if we had x plus 3, our a would be negative 3. In this case, we have x minus 3, so our a is equal to 3. So we take our a, in this case 3, we put it in a little box right here, and we sort this polynomial, the numerator, in descending order. So right now we have it in descending order, having the greatest exponent to the left and having all the exponents to the right less than that. And then we have 3, and all the exponents to the right of it are less than 3, and so on and so forth. So we will write the coefficients in that same order next to the a, to the 3. So we have 4, negative 6, negative 12, negative 10, and 2. Now we will draw a line, leaving some space between the coefficients of the polynomial and the line. So what we will do is, first step, bring down the 4 right here. And so now we will multiply 3 times 4, 12, and we will put it right here. So we will bring it up like that. And then we will add negative 6 and 12, and we get 6. Now we will do the same thing we did before. We will multiply 3 times 6, that's 18, and we put it right here on top, and we will add that to negative 12, getting another 6. Now 6 times 3, 18, we put it right here, we add it to negative 10, and we get 8, and 8 times 3, 24, plus 2, 26. And this right here, the numbers that we get at the bottom are our resulting polynomial, but this last number right here is our remainder. So this is our constant term. The next one is the one with the x, the next one with the one with the x squared, and the last one the coefficient of x cubed. So this is our result. Just to make sure, we will do the synthetic division we did for the polynomials that we use for the long division to make sure that we get the same answer. So as you might recall, we had this polynomial x cubed minus 7x plus 6 divided by x minus 1. And so a is equal to 1 right here. And we already have the the top polynomial in descending order. We will just add, like we did before, the term for x squared. So it's x cubed plus 0x squared minus 7x plus 6. Like that, it doesn't change anything, and we will divide that by x minus 1. So if we do that, here we put the a in a little square. We put 1, 0, negative 7, and 6, our coefficients. We leave some space, and we draw a line. And now we bring 1 down. 1 times 1 is equal to 1, and we add that to the 0, and we get 1. 1 times 1 is equal to 1. Negative 7 plus 1 is equal to negative 6. Negative 6 times 1 is equal to negative 6. 6 minus 6 is equal to 0. So we get that the result is x squared plus x minus 6 with a remainder of 0. As you might recall, this is exactly the same answer we got when we did the long division.